Okay, so we'll continue on. And so now we're going to be talking about, last time we talked about de Moivre's theorem. And well, you guys can see, right? We delved into de Moivre's theorem and did all these complicated deals. But these were all being squared or cubed or going higher than that. What we're going to be doing today is we're going to be taking roots of them. So instead of doing squaring them or doing things like that, we're going to be taking roots of them. And there's a whole process to doing that. So let me explain this to you guys. So let W be a given complex number with its n being greater than or equal to 2. Any complex number that satisfies the equation, and here's the equation, it's going to be z to the n is equal to our W is called a complex nth root of z. Of W. Of W. So z squared equal to W is called the complex square root. Z to the third equal to W then is going to be called the complex cube root, or cube roots. We can call them plural roots. Again, of W. So then we'll let W equal R cosine theta with that little zero there. That's not, meaning the original or origin, plus I sine theta naught be a complex number. And then we're going to let n be greater than or equal to 2, be an integer if z to the n is equal to W. So this is going to be the general equation. We're going to get z to the k, so that's going to be the number of solutions, is going to be the nth root of our r times cosine theta naught divided by n plus 2 pi k divided by n plus I sine, and again theta naught over n plus 2 pi k over n. And this is where my k is going to be integers 0, 1, 2, dot, 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 till we get to n minus 1. Now, one of the things I want to stress is this right here, this n, tells us that we have n number of solutions. Okay? So, just real quick, if I had z to the 5th was equal to something, my z would be equal to something I don't know, but I know that I would need 5 solutions for it, right? Because the power tells me how many solutions I'm going to have. Does that make sense to you guys? Okay. Okay, don't worry. We're going to do some examples so it's more concrete. But just think of it as the number of the power is going to give me the roots number of solutions. So in this example that we have here, it's telling us find all complex cube roots of negative I. In other words, find all of the solutions of x to the third equal to negative I. So the way that we can look at this is really it's going to be z to the third is equal to negative I, right? Because they're asking for the complex roots, cube roots. So that's telling me I'm going to be z to the third, just like I had right here. I found out that I had a laser pointer on this app, so now I'm really happy because you guys can see where I'm pointing. Silly, I know, but it makes me really happy. So then from there, that's going to be equal to, and one of the things that's interesting is that z to the third tells me I'm going to have 3 solutions, correct? And then what I want to do is I want to be able to find where negative I is. So if I were to graph this thing, isn't negative I right here? Right? Based off of our numbers, the x-axis is the reals, the y-axis was our imaginaries, and so a negative I is the same as negative 1 in the imaginaries, so I go down 1, right? So what angle does this create? It's something that we're going to need to know in order to be able to do these problems. So what angle is that? What is that in radians? Or in degrees, I don't care. What angle does that form for you guys? Yeah, it's 270 or 3 pi over 2. So the radius I know is 1, right? Because it's a distance of 1. And then my theta naught is going to be 3 pi over 2 or 270. It's not really that big of a deal which one you use. I wrote my formula in terms of radians, so I'll use that, but I can do it both ways so you guys can see it. So what that's going to do for me is it's going to give me the radius is 1, right? So I'm going to take the third root of 1 cosine of 3 pi over 2 plus I sine 3 pi over 2, right? Now, what's going to happen here, that almost looks like a pi, doesn't it? I don't want that to be a pi. It's the cube root of 1. So what's going to happen here is this. So we have z to the third is going to be equal to cosine of 3 pi over 2 plus I sine 3 pi over 2. But my z sub k, right, because we need 3 solutions, is going to be found by going cosine of 3 pi over 2 divided by 3 plus 2 pi k divided by 3 plus I sine of 3 pi over 2 divided by 3 plus 2 pi k divided by 3, where my k is going to be 0, 1, and 2 because we have to have 3 solutions. Do you guys understand where I got those numbers? You can say no. Oh, why did I divide by 3? So cool. So the formula here that we have, right, tells us my z to the k, my k is going to be 3, right? So my n is the cube root, it's a 3. So do you notice I take my initial angle, theta naught, and divide it by 3? Or divide by n? But my n in this case is 3, so I have to divide by 3 everywhere. So dividing by 3, dividing by 3, dividing by 3, dividing by 3. Does that make sense? Okay, good. And I'm going to show you, instead of getting all crazy and doing it that way, I'm going to show you a more practical way to do it that will be a little bit simpler for you guys, okay? So watch this. So my initial z naught is going to be cosine of what we originally, what is 3 pi over 2 divided by 3? Isn't that going to be pi over 2? Right? Yes. And I'm I'm going to be adding 0 to it because my initial k is 0. Plus, actually, you know, I'll write it down. I'll show you all the steps on this one. And then when I do the next example, I'll do 2 examples showing you all the steps, and then I'll show you another trick in a bit. All right, so this is going to be cosine of pi over 2 plus 0. And the reason it's 0 is because my k, when I first start, is going to be 0, right? On the first example, because that's a 0, so my k is going to be a 0. Plus I sine of pi over 2 plus 0, right? So this is going to be cosine of pi over 2 is 0, plus I sine of pi over 2 is 1. And so my solution to this first one is simply going to be I. So z naught is I. Okay? z1 is going to be cosine of theta over 2 plus 2 pi over 3 plus I sine pi over 2 plus 2 pi over 3. And the reason that happens is because now my k is 1. So I'm going to add 2 pi times 1 divided by 3 is going to give me that 2 pi over 3. And the same over here for sine. I'm going to get 2 pi k over 3. The k is going to be 1, so I'm going to be adding a 2 pi over 3. Does that make sense to you guys? Okay, good. So then I'm just going to, for space sake, I'm going to write it over here. So pi over 2 plus 2 pi over 3. The angle that results there is going to be what's that? It's going to be over 6. So 3 over 6, 4 over 6, 10 over 6. 10 over 6 reduces to 5/3 pi. So cosine of 5/3 pi is a negative rad 3 over 2. And then it's going to be minus 1/2 I. So z1, I'll actually make boxes so you guys can have each one of these and see them. Is equal to that. Are you guys okay with how I got those values? This is where the unit circle becomes so very important, right? Having it memorized. If you don't have it memorized, you're going to go look for all these values everywhere. You'll be getting a little bit crazy. Oh, you missed that part? Okay. So how did I get this 2 pi over 3 here is what you're asking about, Oscar? Okay, so see the formula here? Now, this is z, the 0 is here on this one. What's the z here? Cool. So then that means I'm going to have this, which is the pi over 2, right? Once we simplified it, plus 2 pi times 1 over 3, which 2 pi times 1 is 2 pi over 3, which would give me this. Does that make sense, Oscar? Leah, what were you asking? How did you get the answer for number 3? I don't understand. Did you mean for number 1? For z sub 1? Okay, so I'll just show the work so you can see it, and then we'll go from there. All right, so I'm going to get cosine of, and I'm going to get common denominators, right? So this is going to be 3 pi over 6. This is going to be 4 pi over, 4 pi over 6. So that's going to be 7 pi over 6. I think I said 10 pi over 6, so I messed up. So cosine of 7 pi over 6 is a negative radical 3 over 2. And then by the same token, I'm going to get sine of 7 pi over 6. And sine of 7 pi over 6 is a negative 1/2. So that's how I got this value and this value. Does that make sense? Okay, cool. Yeah, it's all a process, isn't it? But understanding this process is going to be a very, very big deal for you guys. So I do want you guys to understand it. So then z sub 2 is going to be cosine of pi over 2 plus 4 pi over 3 plus I sine pi over 2 plus 4 pi over 3. And does everyone get why I got 4 pi over 3 added to both? Okay, so we're okay with that piece. And then evaluating that, I'm going to get radical 3 over 2 minus 1/2 I. And that's its solution. So we're a cubic, we should have 3 solutions, and those are the 3 solutions. Okay, let me go to the next one, and I'll walk you through it. And then the last 3 that I have are actually a lot more complicated. And so explaining those to you is going to be actually pretty cool, because I'm going to try to do it in a not so rigid formula way. But maybe you end up liking the formula better. All right, here we go. I'm going to try to use like logic to explain it to you guys instead. Okay, so in this example, we're looking for, again, a complex square. So that means I'm going to have z squared is equal to 4i. So when I graph this thing, I always want to have a graph. 4i is up here. So what is this angle here? That's right. So my initial angle is going to be pi over 2, and my radius is going to be four. Does it make sense why it's 4? It's not 4i, it's just 4. How far, if, so let me see it this way. If this is where the center is, how far is it to here? It's just 4 away. Now, another way to do it, if you wanted to do it mathematically, 4i, isn't that the same as 4 plus, isn't it the same as 0 plus 4i? And I told you guys that my radius was 0 squared plus 4 squared. So I would get 0 plus 16. So r is the square root of 16, which gives me r is 4. That's the way to do it mathematically if you wanted to do it. But looking at the picture, you can just see how far is it from the origin. But either one works. We're okay with that? All right. Okay, so what we have then is 4 cosine pi over 2 plus I sine pi over 2, right? But what we have, and one of the things that's important is, so z squared is equal to 4 cosine of pi over 2 plus I sine pi over 2. But we want our z sub k, so that tells me I'm going to take the root of 4, and then I have to go cosine of the initial angle plus 2 pi k over 2 plus I sine of pi over 2, that's a terrible 2, plus 2 pi k over 2. And the reason it's a 2 there is because my n is 2, right? Are we okay with that? So then we should have two solutions, and so our two solutions are going to be z of 0 is equal to 2. We're going to be, since it's 0, we're not going to add anything to it. We're going to get cosine of pi over 2 plus I sine of pi over 2. And so that's going to give me 0 for cosine. It's going to give me a 1 for sine, so I should get 2i. Ooh, I forgot one thing. My apologies. What did I not do? I didn't divide this side by 2. Right? Because it's supposed to be divided by n. The initial angle is supposed to be divided by n. And so this should be over 4. This should be over 4. My apologies. Right? Because the formula tells us we divide by n to the original angle. So then that's going to give me radical 2 plus radical 2i. Are we okay with that? Okay. Z1 is going to be 2 cosine of pi over 4 plus pi plus I sine of pi over 4 plus pi. which will give me a negative radical 2 minus radical 2I. Oops. Okay. Now, may I kind of show you a different way to look at this so it's not so bad? I think it's an easier way to look at it. In fact, you guys give me your opinion. So let's start off just by looking at the picture, okay? Dang it. So if we're up here, this is our initial angle, right? It's the initial angle is pi over 2. So if pi over 2 is that that reference angle that we got from 4i, what we're going to do is take that angle and divide it by 2. So that's going to put us right over here. And this is now going to become our theta naught. Okay? Now, to find out what I'm going to add to it each time, the way I think about it is I think about it as what's the full circle angle divided by the n. So the full circle is either 2 pi, or you can think of it as 360. And when you divide that, it's like going half a circle, right? Since we're going by 2. So then going a half circle distance is going to put us over here. So then this angle is pi over 4. And this angle over here then has to be 5 pi over 4. And so we end up seeing that this angle here, without doing a bunch of math, is 5 pi over 4. And this is 5 pi over 4. Now, something cool. At pi over 4, the x would have been radical 2 over 2. My y would have been also a radical 2 over 2, right? At 5 pi over 4, they both have to be minus signs. So if you look at the two answers that we have, here they're both positive, correlates to that. Here, now we're in quadrant 3, they're both negative, and it correlates that way. But to get this initial angle, first we find out what's the angle that they gave us, then we divide by the n to get our starting point, and then we're going to go full circle divided by the n to know what we add each time. Does that make sense? Are you guys okay with that? Okay. So let's look at these more complicated problems. So looking at this complex root, we're looking for a complex square root. The thing that I want to look at is what quadrant am I in? So based off of this right here, what quadrant am I falling into? Remember, this is my x, this is my y. So where would I be? That's right. We're in quadrant 3 here, right? So since we're in quadrant 3, I'm going to find a couple of things. So, and I'm going to explain it to you different than we did it with the formula, because I think the formula is so dang rigid. So look at this. Let's find r first. So to find r, I'm going to go -2 squared plus a -2 rad 3 squared. That rooted is going to give me 4 plus 12. So my r is going to be the root of 16, or r is 4. We okay with that? Okay, now we're going to go after the angle. So I'm going to go after the angle using tan of theta. So that's going to be a -2 rad 3 over a -2. So tan of theta is going to be radical 3. So theta, tan inverse of rad 3, is going to give me a reference angle. Now this is important that you guys understand this. It's a reference angle of 60 degrees. It's not the actual angle. Okay? So for me to be able to see that, I'm just going to graph real quick. So I know that I'm in quadrant 3. So this is the reference angle here. That's 60. So that means that this reference angle should be 60. So we're down here. Okay? Are we okay with that? So if that was 60, or that was pi over 3, adding pi to it, doesn't this become 4 pi over 3? Does that make sense to you guys, that we're at 4 pi over 3? This would be pi over 3, but that was quadrant 1. We're in quadrant 3. So this is our actual angle. Is going to be, what is that, 240? Or 4 pi over 3. Does that make sense? Okay, so then from here, once I have that, I can go and get my solutions. The n is 2, right? So to get my theta naught, my n is 2. I'm going to go 4 pi over 3 divided by 2, which is going to give me 4 pi over 6, or that's going to be 2 pi over 3 is my initial angle. Okay, so then my initial angle is going to be 2 pi over 3, which is up here. So I'm going to get, okay, according to the theorem, z of 0 then is going to be the square root of 4 times cosine of my initial angle, which is going to be 2 pi over 3, plus I sine of 2 pi over 3. And one of the things that's cool, the way I did it, so if you guys remember, this was the pi over 3 reference. If I know what pi over 3 is, isn't that 1/2 rad 3 over 2? Right? So if I know the reference angle, I'm going to be able to do a bunch of stuff right now. You'll see. Now, square root of 4 is 2. Cosine of 2 pi over 3 puts us in quadrant 2. So instead of it being a positive 1/2, we're going to be at a negative 1/2 plus I, and that's going to stay radical 3 over 2 because we're still above the x-axis. Do you guys understand how I got those numbers? And so that's going to give me, that's going to give me a negative 1 plus I radical 3. Good? Okay, now check this out. Z1, instead of getting all crazy, it's going to be 2 cosine, and I'm going to show you how to get the angle real quick. Remember, it's 360 or a full circle revolution divided by n. So a full revolution divided by 2, because our n is 2 in this case, is only going to be a half circle rotation, correct? And since we're doing a half circle rotation, our other angle should be down here. So this is 5 pi over 3. So this should be 5 pi over 3. Now, since we're in quadrant 4, I'm going to get 2 times. My x is now positive. My y is the negative. And so I'm going to get 1 minus I radical 3. If you do not like the way I just did it, you can continue to use the formula. But I think this is more getting you to understand what's going on with the solutions and how you're rotating around in the complex plane. Okay, good. Good. Okay, want to do the next example? Or do you guys want to try the next example and then I'll do it just so I can see what your potential misunderstandings are? Yeah, why don't you guys try number 10 and then I'll do it after giving you guys a few minutes to try it. How's it going? Oh, okay. All right. Let me see if I can do a little bit. So this tells me that I should be in quadrant 2. Right, quadrant 2. And so first thing I'm going to do is I'm going to find my R. Is that what you guys got for your R? Okay. So since we have that, and we're in quadrant 2, that tells me that my angle should be 120 degrees. Right? Or 2 pi over 3. Is that the angle that you got? Okay. So now that we have that, we need to divide by 2, right? So if we divide by 2, our not angle is going to be pi over 3, right? Did I do that for you guys? Yeah. So let me just show you with a picture again, just so I can be consistent. So 120 is here, or I'll call it 2 pi over 3 since we're using radians. Dividing that by 2 to get our knot angle. What did I do for my knot angle? I did red. So that's going to put us over here. So this is theta naught, and that is pi over 3. And just so I have my other angle, since my n is 2, I should be down here, and that's going to be at 4 pi over 3. That's going to be my theta sub 1, right? With this case, yes, because we're doing squares, right? It's saying square roots. I'm going to divide by 2. This one here, see how it's a fourth root? Since it's a fourth root here, I'm going to divide by 4. Yes. Yeah. So it depends on what the root is, what you divide by. Okay. So then to set this up so that we can do our problems, it's going to be z naught is going to be the square root of 6 times cosine of pi over 3 plus I sine of pi over 3. So that's going to equal the square root of 6. And then pi over 3, we already know what those are, right? It was 1/2 and radical 3 over 2. So this should be 1/2, and this should be radical 3 over 2i. Correct? And so I should get radical 6 over 2 plus, I'll go 3i radical 2 over 2. And that's my solution to the first. Is that okay? Are there any questions on this one? I just want to make sure. You guys okay? Okay. All right. So Z1 is going to be equal to radical 6 cosine of, now we're going to go 4 pi over 3 plus I sine of 4 pi over 3. So that's going to give me radical 6 times, and now since we're in 4 pi over 3 range, both numbers are going to be negative, so I'm going to have a negative 1/2 minus I rad 3 over 2, which will give me a negative radical 6 over 2 minus 3i radical 2 over 2. Is this method making sense? Okay, good. All right, let's do the complicated fourth root one. But you'll end up seeing it's really not that bad. But we'll do it right now. Okay, so what quadrant are we in with this one? Yes. So in this one, we're in quadrant 3. So let me find r first. That's just the habit I've gotten into. So I'm going to go negative 2 squared plus a negative 2 radical 3 squared rooted. So r is going to be 4 plus 12 rooted. So r is the square root of 16. So r is 4. Okay, now to get the angle, I'm going to go tan theta is going to be a negative 2 radical 3 over a negative 2. So tan theta is going to be radical 3. That's my reference. Since I know I'm in quadrant 3, this angle is going to be 240 degrees, or 4 pi over 3, right? That's our angle that we have for our problem. Okay, so picture I always did my initial in red, so I'm going to do that. So the initial angle here is going to be that 4 pi over 3 divided by 4, right? So if it's divided by 4, don't I get pi over 3? In fact, I want to do it this way. So my theta naught is going to be pi over 3. Do you guys agree? Okay, good. Now, I'm going to go full circle divided by 4, and full circle divided by 4 means I'm going to add 90 degrees each time, right? Because 360 divided by 4 is 90, or 2 pi divided by 4 is pi over 2. So we okay with that? So if I add 90 to it, I'm going to end up over here, right? So that I have a right angle. So pi over 2 plus pi over 3, and I'll just do the math on the side. I want to show you how to do it. So pi over 3 plus pi over 2, that's going to be 3 pi over 6 plus, 2 pi over 6 plus 3 pi over 6, which is going to give me 5 pi over 6. So this is going to be 5 pi over 6. And that's going to be my theta 1. Adding a half circle, I'm going to end up over here. So that's going to give me 4 pi over 3. And that's going to be my theta 2. And I have to have a fourth solution, right? So my fourth solution, I'll use blue. And that's going to be with this guy over here referencing. And so that's going to be 11 pi over 6. So, and I should, just so we have it, that's theta 3 is 11 pi over 6. Okay, do you guys get how I got my 4 angles? Are there any questions on those? Just want to make sure. No, we're okay? All right, so then let me find these solutions. So z1 is going to be the fourth root of 4, right? Because it's the fourth root of that. make sure that that's clean. The fourth root of 4, then cosine of pi over 3 plus I sine of pi over 3. So that's going to give me the fourth root of 4 of cosine of pi over 3 is 1/2. This is going to be rad 3 over 2. And we can leave it that way. We can just leave it that way. It's not a big deal. So, yeah, but since you're talking about pi over 3, you want to add pi over 2 as the radians, so you're in radians. If you were talking about it in terms of degrees, you would have gone 60 degrees, 150, 240, 330. Does that make sense, Oscar? You don't want to mix degrees with radians. Okay. This is actually Z0. My apologies. Z1 is going to be the fourth root of 4 of cosine of 5 pi over 6 plus I sine of 5 pi over 6. And that's going to be the fourth root of 4. And cosine of 5 pi over 6 is going to be a negative rad 3 over 2 plus 1/2 I. Do you guys agree with that? We're good with that? Okay, cool. Z of 2. Ooh, and I should box those just so you guys have them. So there's my solution 1. Solution 2. So then here we're going to get the fourth root of 4 of cosine of 4 pi over 3 plus I sine of 4 pi over 3. And that's going to give me the fourth root of 4 of a negative 1/2 minus I radical 3 over 2. Right? You're terrible. Do you guys agree with those values? Okay. And then z of 3, which is going to be our final solution, it's going to be the fourth root of 4 of cosine of 11 pi over 6 plus I sine of 11 pi over 6. And that's going to give me now x coordinate is positive, so that's going to be radical 3 over 2 minus 1/2 I. Does that process make sense? Yeah, no, I understand that. Do you guys want me to show you that first example again, but doing it this way just so you guys can see if it makes more sense that way? Okay, so I'm going to do the first example again. I just want you guys to see it. So remember, they wanted the complex, they wanted the cube roots. They wanted the cube roots of negative I, right? So if we're looking for all the cube roots, when I go to graph it, just real quick, we know that we're down here at negative I. And so the angle that we have is this angle, which we know is 3 pi over 2. But if we would have wanted to find it, we could have found it. And so I'm going to show you all the steps. So r would have been 0 squared plus negative 1 squared rooted. So r would be 0 plus 1 rooted, the square root of 1. So r is 1. Our tan becomes problematic because if we were to do it that way, we would see that we have x is 0, right? And we can't have that. So instead of using tangent for this one, I'm going to use sine of theta, which uses y and r. And so y is negative 1 and my r is 1. So then sine inverse of negative 1 is my theta. So theta would have been that 3 pi over 2. So whenever x is 0, you can use sine instead of tangent. So now we have that angle. Our n is 3 though, right? Since n is 3 because it's a cubic, my initial angle is going to be that 3 pi over 2 divided by 3. And so that's going to put us right here for our theta naught. So that's going to be, our initial is going to be pi over 2, right? Now, remember, it's a 360-degree circle, or 2 pi, and we're going to divide by 3. So that means I need to add 2 pi over 3 each time. Okay? So then 2 pi over 3, my next angle, I think what did I use? I want to be consistent with the colors. Oh, my theta naught was red. Sorry. So this is my initials red. Then adding the 3 pi over 2 to that. So, I'm sorry, 2 pi over 3 to that is going to put us somewhere over here. Because 2 pi over 3 is 120 degrees. So 90 plus 120 is 210, right? But I want it in radians, so I'm going to just do that math real quick. So pi over 2 plus 2 pi over 3, 3 pi over 6 plus 4 pi over 6 is going to give me 7 pi over 6. And then to get my third angle, I don't know, I'll use purple. I'm going to go another 2 pi over 3. So adding 2 pi over 3, that's adding 4 pi over 6. So this is going to be 11 pi over 6. That would be my theta sub 2. This would be my theta 1. And those are my 3 angles. Does that make sense with the 3 angles? How I got them? You're okay with that, Oscar? That makes sense? So then, since I have those 3 angles, I know the radius, I could go find each one of them. So z of 0 would be 1 cosine of pi over 2 plus I sine of pi over 2. z1 would have been 1 cosine of 7 pi over 6 plus I sine of 7 pi over 6. And z2 would have been 1 cosine of 11 pi over 6 plus I sine of 11 pi over 6. And those end up being the same numbers that we had, correct? So the formula, or looking at it and understanding how to use the formula, is so very, very beneficial, right? Okay. Do you guys have any questions on these? No? Okay. So then that means that we will have a quiz on this next Thursday. Okay? There'll be a quiz on this next Thursday. If you guys don't have any questions, I'll go ahead and stop the recording so I can post it.